So good morning, good afternoon, everyone, and welcome to this session regarding BECCS within the CDR30 and COP30 event. So this session is currently being recorded, and so well, thank you all for joining this masterclass. I will be co-presenting with Emeric, so let me just upload the slides online, and then we can go ahead. Right, normally you should be able to see the presentation online right now. Perfect. Okay, yeah, so again, we're excited to be a part of this CDR30, which is a community of carbon removal players who are basically organizing a pavilion within COP30 and so participating in this global event. And today our objective is to present learnings from Carbon Rhine Route, which is a European project dedicated to one of the CDR ways, which is called BECCS. So I'll be glad to present this today. My name is Karim Romani. I'm a co-founder and CEO of Carbon Impact. We are a developer of bioenergy with CCS projects based in France. And I will be co-hosting and co-presenting this event today with Emeric Raymond. Hi, Emeric.
Hi, everyone.
So Emeric is head of project development at Airfix based in Switzerland, and I'm personally based in France. Yeah, maybe Emeric, you can give us a few words about Airfix.
Sure thing. Yeah. So Airfix is a BECCS project developer in a sense. So we support BECCS projects with advisory on the entire value chain, going from after the capture, so transport, storage, carbon certification, and monetization. And we support projects at advisory stage, so early stage, pre-feasibility study, for feasibility studies, and then throughout the project development. And we also support on the monetization side with the sale of CDRs from those projects. So that's also how we work with Karim and Carbon Impact, and how we complement each other.
Yeah, thanks, Emeric. So Carbon Impact, as I said, is an independent BECCS project developer. So we're basically a team of engineers co-founded by Alex and myself. We have a background in power generation. We are based in France, and we are developing a portfolio of projects to capture bio CO2 and sequester it in a permanent way. And in this case, we are actively cooperating with Airfix and other partners such as Chemoil, Northern Lights, and South Pole in this research project. And the idea today is to share the learnings from this project so that they can benefit from what we have learned so far. This project has started 2 years ago. It's still ongoing, and the idea is to share disseminate the knowledge with the global community today. So just to give maybe a quick presentation of Carbon Rhine Routes, which is the name of the project. It's the aim is to establish a commercial multimodal CO2 removal value chain across Europe. So to really implement value chains where CO2 is being captured and then transported and sequestered permanently. And the idea is to demonstrate the whole value chain for all the parties and to explore and resolve the various issues that can happen, including the ones around, well, obviously technical aspects, but also around business models and risk sharing. And the idea is to ensure that this is a first, pioneering project and value chain exploration, but this will allow over time to incentivize all the parties and all the participants in this future value chain to optimize the value chain, the cost, and as well the emission efficiency of the whole thing. Maybe Emeric, you can tell us a word about the structure and the approach that was taken in this project.
Yeah, sure. So we split into the project into 4 main work packages. So one is trying to gather as many emitters or in and around the Rhine area as we see that the clusters can help to bring the transport and storage costs down, mainly transport. So the work package 1 was really to try to bring together as many emitters as possible and try to identify potential clusters of emitters to find efficiencies. Work package 2 and 3 was looking at transport and then storage and what are the different options existing today, and how those options will evolve over the next 5 to 10 years, and how to plan for the projects today and the projects of tomorrow, basically. And overarching is really the business models for BECCS projects and risk-sharing structures. So this is cross-cutting across all 3 work packages, and looks at what kind of revenue solutions are available, and generally how the risk is shared along the value chain. And this event is also part of work package 5, which is basically sharing the knowledge, as we see it beneficial for all projects and potential emitters to want to pursue the BECCS approach.
Great, yeah, thanks a lot, Emric. So as this is an event destined to, let's say, a global audience, and depending on your level of understanding, we thought it might be useful to have some basics first explained. So we'll go through just explaining the need for carbon removal in the first place, and then what are the different methods, how BECCS is one of them. Because we have already started using lots of acronyms, so we'd like to take maybe some perspective and explain the basics, and then we'll a bit deeper into the findings from the project itself. So in terms of general perspective, the idea here is that BECCS, bioenergy with carbon capture and storage, is one of the methods to what we call carbon removal or CDR. And so the most easy way to explain it is that we are here today as part of COP. The idea is to talk about the climate challenge, and the climate challenge is due to an accumulation historically of CO2 in the atmosphere. So when you look at the CO2, that's the concentration of CO2 in the atmosphere, which is basically constant. You can measure it, and it's the same value more or less everywhere on the planet. It has gone from slightly below 300 ppm, particles per million, in the 60s and generally before the Industrial Revolution. And we are now today reaching levels of 425 ppm. And basically, the climate science tells us today that the damages that will be incurred by the human communities and also by the natural ecosystems are really proportional to this value. So the bigger the concentration in the atmosphere will be, the biggest will be the damages. And so the idea is to the problem we have is that by burning fossil fuels, we have accumulated and used the atmosphere as a kind of waste storage facility for 2 centuries, and now we wish to do something about it. And so you can see this from what are the climate scientists telling us, and including in the latest IPCC report, the summary one, the summary 6, sorry, that took place a few years ago, now in 2022, and clearly stating that this methods of carbon removal, so taking the CO2 from the atmosphere and putting it in a sink, is something which is unavoidable if we want to reach net zero, and therefore if we want to have the climate problem under control. And you can see this on the right side of the chart. Basically, we first need to focus on decarbonization. So this is the main task, to bring the emissions to the lowest level possible. However, there will be some residual emissions, some hard to abate sectors, for example, in the industry or in aviation, and they will require, in order to reach net zero and to stop the accumulation of CO2, to be counterbalanced by these carbon removal methods. And over time, as we decarbonize our system and we increase the dark blue side, which is the carbon removal we're talking about today, we can then start to reduce the atmospheric levels of CO2 and bring them to a more safe situation regarding the atmosphere and human and other ecosystems life on the planet. So I think now it's established that the carbon removal is really needed. How to do this? And this is where I have to say it's something which is, science tells us that it's a mix of methods. You can see on the screen an extract from NGO or think tank Carbon Gap, which is a specialist of carbon removal advocacy in Europe. And in this chart, you see that carbon removal actually is a portfolio of methods. It's not one thing. And BioCCS or BECCS, as you can see in the highlighted area on the right, is only one of those methods. So I will not go through into details of this slide. I just wanted to make you understand that we have a portfolio. No one of these methods can reach the high values we will need to achieve in 2050 because we're talking about gigatons of carbon removals that needs to happen by then. However, there are groupings of those methods that are there. So on the left, for example, you have methods based on restoring natural ecosystems like forest or soil or coastal areas and to improve their ability to sequester carbon because they do this naturally, for example, with photosynthesis. However, these methods have limitations in terms of quantities of CO2 they can absorb, and they have also limitations in terms of permanence of the sink of carbon. On the other end, you have engineered carbon removal methods, such as, for example, DACS or DOCS. So here we go into direct air capture or direct ocean capture. You'll take the CO2 directly from the ocean or the atmosphere and put it underground for geologic storage. And those methods are also have a high, they are easy to measure, but they are energy intensive, and so they require investment in new footprint. And today they are really emerging and starting from very low levels. And in between, you have methods that are based on the biomass, methods that are based on the geochemistry of the ocean, like ocean alkalinity enhancement, which allows to increase the geochemical capacity of the ocean to sequester carbon in a durable way. And these are emerging methods. And so biocarbon removal and storage, or bioenergy with carbon capture and storage, which is our focus today, is one of those methods. And it consists in taking CO2, basically capturing it at bioenergy plants like biomass or biogas plants, and then sequester it underground geologic formations, which are the ones where we will typically go and look for hydrocarbons in the first place. So these are formations which are 800 to 3,000 meter deep, which have capacity to store large quantities of CO2 and in a more or less permanent way. And this is one of the emerging methods to remove carbon from the atmosphere, and it is limited by the availability of sustainable biomass over time in the economy and in our activities. So just to give you an example, for example, in a situation in Europe, we have a big network of plants which are biogas plants. So you see on the left side, we have more than 1,000 biogas plants in operation in Europe. They basically handle they process waste from agricultural activities or the food processing activities or even waste processing activities, and they generate biogas, which is a form of energy. And in general, in this biogas, you also have a part which is usable for energy, which is the methane, and you have CO2. So these facilities that you have on the left are a source of bio-CO2, which comes initially from the atmosphere. On the other hand, you have a number of developments, typically in the North Sea on Europe, where we are developing geologic storage capabilities. And typically we have in the CO2 Rhine Route project the chance to have one of them and one of the pioneers called Northern Lights, who have the first facility in operation currently in Europe, offshore Norway. And there are others which will come online in the next few years. So as you can see, there's a potential to capture the CO2 from these thousands of plants, which have CO2, which is relatively easy to capture. We'll come back to that later. And then we have geologic storage coming online, so which will allow for a great potential for potentially millions of tons of bioenergy with CCS projects and hence carbon removal that can take place in Europe using this method. So maybe to go a bit more into the details now regarding the way this works. So at the end, for BECCS or bio-CCS, you always have initially a bio plant facility, like a biogas facilities, the one I have described earlier, processing agro residues or food residues into biogas. And you have also other types of plants, for example, biomass combustion plants, which are burning basically, for example, forestry residues to create electricity and or heat. And so these are different types of facilities, but they both generate this bio CO2, which was again initially captured from the atmosphere. So in all these cases, you need to perform different steps. So the starting point is the biogas or the biomass plant. In case of biogas, we have high concentrations of CO2 coming out of these units when they do a separation of biogas. And so you need basically to condition it for transport. And typically, the biogas will be then, and the bio CO2 will be once separated from the biomethane, will be liquefied for transport. And so that liquid CO2 can be put onto trucks or trains or ships and to be shipped this way to the underground storage facilities. When you have biomass combustion, you have a slightly more complex process because in biogas plants, the CO2 is very concentrated. We're talking above 95% of CO2 in those plants coming out of the units. In biomass combustion plants, we're talking about flue gas, where generally we're talking between 10 and 15% of CO2 concentration. So it means generally we need to have a carbon capture facility, which is an industrial equipment which will process the CO2 from those flue gas, make it more concentrated flow of CO2 that will be either directly into pipelines and to be sent via pipelines to the storage facilities, or going back to the liquefaction step and then being transported in liquid form again to those geological facilities. So the concept is quite simple, but the implementation requires a number of steps which needs to be addressed in detail. And this is basically our focus in this project, to make this a reality in first pioneering projects in Europe. Maybe a few words regarding the carbon capture technologies. So this is an emerging field, and it's technologies that have been developed since many decades, typically in the oil and gas industry. And so there's a number of ways to separate CO2 when it is not highly concentrated, like typically 10 or 15% from a flue gas, from a gas mix. So one of the ways is to do pre-combustion technologies. So it's a family where there will be actually a separation upstream of the CO2 from the rest of the gases by applying processes which will integrate gasification. So it's thermal treatment of the form of biomass or fuel, and to generate at the end a form of gas which is highly concentrated in CO2. So this cannot be applied really on the existing biomass or biogas facilities. It's something which implies plants that needs to be fully designed from the beginning to perform that type of separation. And so it's still at a kind of early stage today of implementation. Another method which you have is to use oxy-combustion. So this is a way to basically burn the fuel or the biomass using a high stream of oxygen. And so this will allow, so it means you avoid to have all the nitrogen in the air coming through the whole process. So it's more optimized. And again, at the end, you have a very pure CO2 gas that comes out of the unit, but it requires to provide oxygen from the beginning. And so it means you have some energy consumption and a different process than usual biomass plants today. And so this is why it's also something which is less also mature, needs to be tested in new facilities which are coming. There's a number of basically test facilities and even production facilities coming online, but they are still at an early stage. So it means that for our project, we have decided to concentrate on what we called post-combustion technologies. So here you take the CO2 directly from the flue gas as it is, so you don't change the operation of the biomass plant, but then you separate it using different physical or chemical processes to get CO2. So this is the one we're going to focus on, and we have focused on for our for our projects in around the Rhine. So in terms of separation of CO2 from the gas mix, you have basically 5 large families of techniques that exist. You have either absorption, where you use generally a liquid process which will react chemically or physically with the flue gas. And then it will bind the CO2 with this solvent, for example, including some amines, which is a basic component. And then at the end, you need to regenerate this solvent, which has captured the CO2, for example, with heat, to recover a pure stream of CO2. So these methods are the ones which are the most mature technically today. There's a number of units in operation. It's something that's been used by the oil and gas and other sectors for a long time. And so we can say today this is something which is commercial. They have still some trade-offs. They have big energy penalties and some potentially emissions of toxic elements. But today it's something which is happening at a commercial scale. But there's also a number of other processes which are in development, which are promising for the future, which allow, for example, less need of heat to regenerate the solvents. Typically the adsorption, you have some components which are basically solid sorbents, which can absorb the CO2 because they are very porous materials like zeolites or MOFs, which have been a subject of the Nobel Prize this year. And then you can regenerate. So these sorbents act like a sponge for CO2, and then they can regenerate the CO2 with heat or pressure, and then you can get back your CO2 in a pure form. So some technologies and some companies are focusing on those methods, and probably we'll see over the next few years as deployments come, if they manage to have better performance in terms of energy or operational safety and emissions of toxic components. Then you have cryogenics, which is basically using cold. So these are also mature technologies, but applied recently to the flue gas of equipment. And these are technologies based purely on electricity, so you don't need heat. You can also use membranes. There's development in the membranes manufacturing that allows more and more robust membranes with better performances, which allow also to separate the CO2 from the rest. And some systems use also biology. So this is a vast array of possibilities. There's lots of research projects. You have around a bit less than 100 commercial companies globally that provide all those types of capture equipment. Again, the most mature are the solvent ones, but others are coming. And so we expect this to be a very evolving field, which allows more and more to have better performance of this capture of CO2 from biomass plants, but also from industrial plants, of course. So here are a couple of examples quickly of units which are running today in Japan, in the US, in Europe. So as you can see, these are big facilities, but which are today in operation, and that allow us to have more and more information about how they work, their performance, and the different parameters in terms of cost and energy use of those facilities. So once you have captured the CO2, and we're getting into the one of the focus of also the CO2 Rhine Route project, how do you transport it? So typically you see here a nice picture of what we call the isotainer. So this is a container of 20 tons where you can store liquid CO2. And in this container, basically it's a basic unit that you can put on a truck, on a rail, or even on a ship, on a container ship, and transport your CO2 from the point of capture to the point of storage. And these options are available today. So this is the first projects that are taking place and starting operations in the next, today and in the next few months and years, we'll be using that type of method. And we expect the transport modes over time to become more and more bulky, so to allow larger and larger quantities, and so to decrease costs. Typically, you can have bulk shipping on barges for when you are, for example, around the Rhine in Europe or other rivers, and also bulk CO2 shipping, as is happening today, will start to happen offshore Europe to store the CO2, for example, in Norway. Over time, we expect also a network of pipelines to develop in places like Europe where we can have much more massive ways to transport the CO2. And so again, to decrease the cost, another factor, but will be this will probably take a few years and not be operational between 2030. But first, plannings are being done right now to ensure that these pipelines and this CO2 infrastructure is being built across the continent and in other geographies. In terms of storage, so we have here an example of a couple of projects which are, so the first one is Northern Lights in offshore Norway. So this has started operations recently, actually, for the first phase of the project, which will capture around 1.5 million tons per year of CO2 per year. And so this one is Northern Lights, and it's a consortium of multiple companies which have, with the support of the Norwegian government, which have started this really first of a kind project in Europe, demonstrating this value chain, and Northern Lights will also expand capacity in the next few years. Another one is Green Sand, which is offshore Denmark. And you see here a platform where CO2 containers basically will be sent to the injection well, which is offshore. In the case of Northern Lights, the injection well is underground and is sent by pipe from the onshore facility that you have on the picture. And these are very large infrastructure projects, but they are starting to happen. And there are developments in other countries, such as Iceland, other countries around the North Sea, like the Netherlands and the UK, and as well in the Adriatic, for example, offshore Italy. So the options to store are increasing over time, and the first units are being built today and starting operations. And an ecosystem is actually taking shape in Europe to ensure bigger and bigger capacities of CO2 storage will be available for storing, including biogenic CO2. So with that, I'm happy to hand on to Emeric to go through some of the learnings from this CO2 Rhine routes, from the actual learnings of the project. Emeric?
Thanks a lot, Karim. We can start, I think, also start with the positive. So like Karim mentioned, we started the project in 2023, and it's running until next year. And 2025 was a very positive year as we reached a couple of milestones. So you can move on to the next slide, Karim. Yeah, so we had basically we have one pilot, let's say flagship project in Switzerland, and that reached a couple of milestones this year across the entire value chain. So the project was registered with the Swiss carbon standard in September this year. So it was the first BECCS project to be certified under the Swiss compliance scheme. It's also the first time that we ran a full, let's say, public tender for CO2 storage, CO2 transport. So we had around 15 or 10 logistics companies that submitted around 15 concepts for transporting CO2 from Switzerland to the North Sea, using existing transport modalities. And we've chosen the operator that will start to transport the CO2 next year by truck and rail. And finally, we're in the last steps of signing a long-term geological storage agreement, which would basically then kind of finalize the full value chain, since the project had already secured revenue 2 years ago. So moving on to the next slide, we wanted to share some of the key learnings from these developments, from the developments over the last 2 years. So in general, on the emitter side, we see a high demand for feasibility studies across Europe, and also around the Rhine, in Germany, in France, in Switzerland. There is a lot of interest from emitters with relatively high purity CO2 that realize now that there is something to do. There is the possibility for them to have further impact with their existing plants, and they are looking into how how this can be done, what are the costs, what are the business models that they can run, and basically how does that look like from their point of view. The limiting factor for most of these projects is the revenue stream. Depending on how much you know, the CDR market and the carbon market in general is quite volatile. And at the moment, the CDR market in particular, where the credits and the certificates costs are quite high, basically between 200 and 600 euros per ton. The demand for those are quite limited, and generally the ones that are on the cheaper side, between 200, 300 euros, they are at that price because they've received some type of public subsidy, which means that without the subsidy, it's very complicated for projects to create a viable business model. What we see, though, is that there are small-scale projects that are successfully advancing, like our first Swiss project, and will start capturing, transporting, and storing CO2 already next year, or between 2026 and 2028, and that larger projects will start capturing, transporting, and storing CO2 rather towards the end of the decade or beginning of the next. On CO2 transport, there was one of the key learnings is that we need to compare solutions based on the real cost. So what do we mean by real cost is that there's the financial cost of the transport. So the fee per container, basically, or per ton of CO2 transported from point A to point B. But in the process, there are some emissions, not a lot, but they do impact the net CO2 removed from the atmosphere, which means that they impact directly the number of certificates that can then be sold, which means that they actually impact the final cost of transport. So when you compare different solutions, you need to compare them including the emissions. And basically, you also need to compare their robustness. Basically, how often do you risk having interruptions? Because on the other side of the value chain, the transport or the storage providers need a regular flow of CO2, which means that you need to have some buffer also for the transport. And in general, the more detail you have on the point source and on the storage side, the more detailed the transport quote. So it's good to run these not too early in the process. The other learnings are more generic. So there is the possibility to leverage existing transport solutions, truck, rail, and with isotainers, as Karim described it before. There is the possibility also to mutualize some of the intermediate infrastructure. There are a couple of projects already that exist like this, like CO2 Next in Rotterdam. There's also a project in Wilhelmshaven to create CO2 hubs at specific ports. At a smaller scale, you can even mutualize things like the quality testing or the liquefaction. And finally, the customs clearance and regulatory requirements are still a bit unclear for CO2. An example of this is that CO2 is considered waste in Switzerland and not in other European countries, which means that the regulation has to be handled and the customs clearance has to be handled accordingly. And since it's a bit new for a lot of the customs organizations, agencies, then this is something that the first projects will have to handle and where we expect some friction as well. Moving on to CO2 storage. So most of the CO2 storage sites require financial guarantee, which either has to come from let's say, mother company or from a financial institution. This is important for emitters to know early on because this can be a limiting factor, especially for smaller organizations. It's important when negotiating a storage contract to balance the responsibilities between the storage provider and the emitter, and to set clear condition precedents, as a lot of storage sites are or either have, for example, the exploration license, but they do not have the operation license, right? And it needs to be very clear for the emitter at which point in time they will have the firm validation that they can operate and not only explore. So this is something to look out for. And generally also the risk allocation between the storage site and the emitter. So at what point is the risk transferred and is the ownership of the CO2 with the storage site? And of course, who has the claim? So we want to avoid double counting. So who has the claim to the CO2 that is stored? Usually this stays with the emitter, but it's important that this is mentioned in the contract. The business model part is a crucial one to these projects, as I mentioned earlier, and this is a key limiting factor and something, a point that has so far restrained quite a lot of emitters from advancing in their project. So it's important to tackle this very early on, to also explore alternative business models that don't only depend on the CDR market, which is a bit more uncertain. So, for example, we've worked with several waste-to-energy plants on how they could adjust their models through different gate fees or through policy changes and adding basically the cost of CCS to the cost of waste processing itself. So there are a variety of ways that can be explored. Some of them do require policy changes, but it's important that the sector starts to explore beyond the CDR market as well, and that they look at the options to finance carbon removal through different business models. And finally, through risk sharing is a key part also of this project. So we've built let's say, quite large risk matrix across the entire value chain. We try to really clearly define where the risk is transferred from the emitter to the transport provider to the storage provider, and basically see how, at which points of the value chain is there a risk that is not allocated and how, or that is, let's say, not addressed, and how this can be hedged by the project owner through insurance schemes, for example. Yeah. So to wrap up, so we have the start of operations of the first Swiss BECCS project, which should be mid-2026 or Q2 2026. The construction is already ongoing, and we're now finalizing dotting the I's on the transport and storage. And we expect that 2026 will be a year of operationalization and also debugging the value chain, as we do expect that there are still some surprises for us along the way. We'll continue to onboard more emitters and transport and storage providers to try to scale the CO2 network and replicate this model with other BECCS projects. We'll continue to explore and experiment alternative business models and communicate on the climate impact and generally on the projects that we develop, and hopefully try to strengthen societal acceptance. And we continue to try to push the topic of BECCS to be explored at the policies level, and to really agree basically together as an industry what we consider to be a robust climate project, or what would be a robust BECCS project. Looking also at the biomass aspect of it, which is extremely important, which is not covered in this project, but which is one that we pay a lot of attention to at Airfix and Carbon Impact. So yeah, that's it for me. Karim, I hand it back to you.
Yeah, thanks, Emmerich. So, and thanks for a lot for your attention. I think we have a bit of time. We're I think a small audience today for this first session. So please feel free to, if you have any comments or questions you have for Emmerich or myself, we can dedicate some time for a quick Q&A session. So yeah, if you have any questions, please, you can raise your hand, or even knowing that the session is recorded, but if you're okay with showing your face on the screen, yeah, that's your time. So don't be shy.
I'm just allowing camera and microphone for everyone because our default settings don't allow it.
Thank you, Anna.
So just bear with me for a second. Thank you.
Sure.
Okay, everyone should have access to both microphone and camera now.
Okay, and I guess they can also put, yeah, the chat, yeah. Okay, thanks. So are there any questions or comments? I guess not. So, Enric, I think we can consider that you have been clear on our presentation. Sorry.
See,
Okay, yeah, you're welcome. Very welcome. Thanks a lot for your attention. This session will be available on the YouTube channel of the CDR30 event. So I wish you a rest of evening or morning, depending on your location. Then don't hesitate to get back to us if you want to have any further exchange on the topic. We're happy with Emric and the rest of the CO2 Ride Route team to follow up. So with that, I wish you all a nice evening and hope to see you soon. Bye, everyone.
Thanks everybody for joining. Have a nice evening.